let's start with the limiting reactant concept. The limiting reactant concept is the hardest part of the stoichiometry. So we are following up with the stoichiometry basically. So if you know that stoichiometry, you think the stoichiometry is hard, limiting reactant is the hardest of it. So let's explain it with something like we do in the kitchen, like making pancake. For example, I want to make 20 pancakes for 20 people. So I need 1 pancake for each person. And when I go to my fridge, I have 3 cups of flour, 10 eggs, and I want to see, can I make 20 pancakes for these people? Or I should buy more, basically flour or eggs. I should do some calculations. So what I do, I have 3 cups of flour, right, in my fridge. So I said, okay, I can make for each 1 cup of flour, based on this equation, for each 1 cup of flour, I can make 5 pancakes. So how many pancakes I can make with my 3 cups of flour? 15 pancakes. What about 10 eggs that I have in my fridge? So I know with each 2 eggs, I can make 5 pancakes. Imagine I use this equation to make my pancakes. So 10 eggs, so with 10 eggs, I can make 25 pancakes. Now tell me, do you think which of these I can make really in the kitchen? Can I make 15 pancakes or 25 pancakes? I can make only 15 pancakes. Why? Because I will be done with my 3 cups of flour. So when I'm done with 3 cups of flour, I cannot have any more flour. So I cannot make more pancakes. I can just make some scrambled eggs or some boiled eggs for my guests. So here we call the flour a limiting reactant. Limiting reactant is a reactant that used up first in the chemical reaction. Completely used up in the reaction, is gone in the reaction, and we don't have any of it in the end. But the other one, which here we call egg, is excess reactant. So if we calculate, we use only 6 eggs to make 15 pancakes. I have 4 eggs excess in the end of the reaction. So egg here is excess reactant, and flour here is a limiting reactant. And the 15 pancakes here is the really, in the calculations that I did, I can make 15 pancakes really if I go to the kitchen. Maximum pancakes that I can make. This is called theoretical yield. The amount that I can really make in the kitchen is 15 pancakes. So basically, with these 3 cups of flour, I cannot make 20, and I should rush out and buy more flour. So in this coronavirus situation, so I guess it's better not to invite people for now to my home. Okay, so let's go to the definition. The reactant limiting the amount of product and making a smaller product would be limiting reactant. The smallest amount of product is called theoretical yield. Okay, let's go to the actual question that is given in the exam. So you might be familiar with this equation that I gave in the stoichiometry. So we always should know that in the stoichiometry and in limiting reactant questions, we should have a chemical equation. They are given in the exam, or they give enough information to write the formulas of them in the exam and make the chemical equation in the exam. Make sure double check is balanced. That's really important, guys. If it's not balanced, all of your answers is wrong. It depends on the instructor. If they are nice, they give you some point. If they are not nice, they are strict, I can say, they don't give you, so you get 0 in the exam. So make sure always double check if it's balanced. Even if you see some numbers, always double check if it's balanced. So let's go to the question. Consider above equation. If I have 1 moles of H2 and 2 moles of N2, which compound is limiting reactant? You might ask, okay, how I should know that this is a limiting reactant question? That's a really important question, guys. Okay, let me give you a hint. Whenever they give you the amount of each reactant in the question, or at least 2 of the reactants in the question, this is a limiting reactant question. Okay, so if they give you the amount of reactants in the question, here they give me 1.5 mole of H2 and 2.5 moles of N2. This is limiting reactant question. Even if you don't know what it's asking for, this is a limiting reactant question. Okay, so another that you can pay attention is which compound is limiting. So they just very obvious asking for limiting, or they ask for what is the theoretical yield. For sure, to find the theoretical yield, you should first find limiting reactant. So this is another one. Or they can ask, what is the maximum amount of product that can be made? So for sure, if you remember from the flour and eggs to make pancake, the maximum I could make was 15, right? So they just ask for telling what's the maximum product can we make, is basically they telling just find the limiting reactant and find the theoretical yield. They just kind of make it complicated, you know. Okay, always I recommend you to kind of abbreviate it. Just put the moles next to each reactant. And another thing before I continue, make sure limiting reactant is always a reactant. Is always from the left side. So it's either here is H2 or N2. Okay, so limiting reactant is always one of the left side reactants. So for this, to find the limiting, if you kind of compare it with the flour and eggs, we always try to relate each reactant to product. We relate each reactant to product. How we relate it? We should go back to a stoichiometry. We relate them using their coefficient. We relate each reactant to product using coefficient. So we start always with a given number. I start with a given number. For example, it doesn't matter you start with which of them. I want to start with 1.5 moles of H2. Then I use a coefficient to relate to what? To relate to the coefficient of my product. So the rule here is, guys, to relate the reactant. You can see in the second step. Relate each reactant to product. Just write it somewhere, guys. Relate each reactant to product. So we relate teams using the coefficients, and then we are done. We find the amount of product. Here is in mole is okay if we have it in mole. Let's do the other one. You cannot decide yet which one is limiting. So then I go with the second one. I start with the given number of N2. We related N2 again to the product. 1 mole N2 to 2 mole NH3. And I have 5 mole NH3. Now double check, guys. You should have the same L compound in the final nominator. You should have the same. Here I have NH3. This is the really important part, guys. Make sure to double check you have the same compound or product at the end, top of the nominator. Then you have 1 mole NH3 and 5 mole. So which one do you think I can make? I can make 1 mole or 5 mole. We said that the limiting reactant always produces the smallest product. So we can say here, my H2 is limiting reactant because it produces the smallest product. So it's the one that used up first in the reaction and is gone through the reaction. And my 1 mole NH3 is theoretical yield. So that's the really correct answer, guys, in the exam. Okay, so let's do another one. I want you to pause here and see if you can do it yourself. Okay, let's double check if we have a correct balanced chemical reaction. Yes, I have a balanced one. So then we start with a given number. It does not matter which one you want to choose first. 1.8 mole of titanium, and relate my each reactant to product, So I have the 1.8 mole of titanium chloride, and here I have, when I relate it to the product again, I add the chloride to product, I have 1.6 mole of TiCl4. So the limiting reactant always produces the least amount of product. So Cl2 is my limiting reactant, and this is my theoretical yield. My TiCl4 1.6 mole. TiCl4 is my theoretical yield. Okay. In another question, they might give you gram of the reactants instead of the mole of them. So what you should do first, guys, when they give you gram of them, first convert to mole. So we should first convert to mole, and the rest will be the same as I talked about. So let's do this question. So we make sure, double check that this is the balanced chemical reaction. So we start always with a given number, and we make sure use the atomic mass of sodium. We convert to the mole, and we use the coefficients to relate the reactant to the product. Here we also start with the given number in the question. We convert to the mole, and then we use the coefficients to relate to the product. So pay attention, you have the same product at the end. So which one do you think here is a limiting reactant? Yes, Cl2, because it produces the least amount of product. And the 1.86 mole is a theoretical yield. Okay, let's do this question. This is basically the same as the last question, but it's asking for finding amount of excess reactant that left over in the reaction. Let me give you a hint, guys. When they give you gram of compounds in the question and they ask for amount of excess reactant that left over, always try to convert the mole of product to the gram of product. How? So let me tell you guys. Let's see. Is it balanced, guys? Chemical reaction. So it's balanced. So we double check. Then, so what is excess reactant, guys? I talked about it. Do you remember? We know already the Cl2 is limiting. If you go back to the previous slide, we calculated the Cl2 is limiting. So Na is my excess reactant here. Why? Because Cl2 is completely gone, is limiting in the reaction, is gone. So Na is the one that is excess, is going to be left over at the end of reaction. Imagine if you have a beaker that your reaction happens there. At the end of reaction, you have some solid left over, solids of sodium left over at the end of reaction in the bottom of beaker. So how we answer this question? So we should first find the limiting and theoretical yield. I recommend you guys, whenever, to be honest, whenever they give you a gram of the compounds, I recommend you to always find the product in the form of gram. Okay, so how? So we start with a given number, we convert to mole, we use the coefficients, then to convert to product, and then I basically find the molar mass of my product and I convert to the gram of product. I do the same for chlorine. I convert to the mole of chlorine. I use the coefficients to convert to product of NaCl, and then I use the molar mass of NaCl to gram of NaCl. So just as a rule, whenever they give you gram in the question, not to make it complicated for you, just go one more step to convert it to the gram. But so obviously it's not always necessary, but I recommend you to do that. So we already see that, okay, because chlorine is producing the least amount of product, 108 compared to 135, this is the limiting Cl2, and 108 gram is my theoretical yield. If in the question they don't ask you if the theoretical yield, they don't ask you in the gram, here specifically they told you to put in gram. So for sure we should convert to the gram at the end. But even if they don't ask you here in the gram, they just say limiting, reactant and theoretical yield, just this, you do not need to find the gram of it. You know what I mean? Okay, so how we can find the excess? So we found already the theoretical yield and limiting. How we find excess? We already know Na or sodium is excess. So for always we start with the limiting reactant here. We start with the limiting reactant here. And we always, when you have a gram, you convert to the mole. Then you relate your limiting reactant to your excess. How you relate them? Using the coefficients. 2 mole of sodium to 1 mole of chlorine. So relate your limiting to excess. Then we convert the mole of sodium to the gram of sodium. Because here they are given numbers are in gram, is better to convert to gram here. Other than that, it will be a little bit difficult. You should convert first. If you don't convert to the gram, you should basically convert your excess to the gram, to the mole first, to be able to subtract from it. Okay, So what is this 42.7 here, guys, gram? Is this our final answer? No, it's not the final answer, because I relate my excess with my limiting. So the limitings are gone in the reaction. So this is the amount of sodium that is used in the reaction, is reacted with chlorine already. So how I can find the excess that left over? We should subtract amount of my given number of sodium in the question minus amount that is used. This is the amount that is left over in the reaction. Okay, this is the complete answer when they ask for excess reactant in the amount of excess reactant left over in the reaction. So what about, guys, percent yield? You might have heard of percent yield in, for example, in your life. Percent yield is the actual yield over theoretical yield. We already know what is the theoretical yield, right? Theoretical yield comes from the relating limiting reactant to the product. That's the theoretical yield. We can calculate it by having the amount of the reactants, just that, and relate it to the product. I can just calculate it. That's what I did in the previous slide. The actual yield is what is you find in the lab. Whenever you do the lab, I find it when I go it. Actually, I do the experiment by hand. I find the actual yield. Like whenever I did the calculations to find how many pancakes I can make, I could make, in theory, in the calculations, I could make 15 pancakes, right? But when I go to the kitchen, I cannot make 15 pancakes because I can split some of the flour on the floor. I might make mistake in calculating. I'm like mixing up, like I use like I don't use my my cup properly to choose a specific amount always. So it's all, guys, error. Always experiments have error. So this is called actual yield. If I, out of 15 that I calculated on paper, I can make only 12, so I have 12 over 15, that would be time 100, that would be the percent yield of my experiment. Okay, so this is called a percent yield. So always they provide, guys, actual yield in the exam, because you cannot do for sure the lab in the actual lab in the exam. So they always provide you with the actual yield in the exam, so you do not need worry. I always give you in the exam, but you should for sure be able to calculate the theoretical yield in the exam first. So for example, suppose the mixture of reactant calculated and the theoretical yield is this one. So they made it easy for us. They already gave us the theoretical yield of SO2 and the actual yield in the laboratory is 42.7. Okay. So how we can find the percent yield, guys? We have the actual yield, which is 42.7, and this is my theoretical yield. And then I multiply 100, it's 57.9. So for sure, whoever has done this experiment in the laboratory did not do a good job, because we want to have closest as possible to 100%. You know, if, for example, you do in the lab and you get closer to the 73.7 in the laboratory, so for sure you will have answer closer to 100. So the best answer that could be here, it would be 100%. But depends on the person that do it in the laboratory, is gonna be different. To be honest, we never can have 100% yield, because there is always something happens, and it's always not perfect, the laboratory stuff. Okay, but the actual yield, as I said, will be given in the exam. So you're gonna just divide it by your theoretical yield time 100 to find the percent yield. Okay, so let's finish this part with a question that covers everything that we talked about. Here we have the question, so make sure that you read the question until the end always. For sure, the limiting reactant question one. So it says we have a balanced chemical reaction. Although it says balance, I never trust. I always double check. So I have 4 hydrogen. I have 4 hydrogen in the right. I have 2 sulfur. I have 2 sulfur in the right. I have 6 oxygen in the left. I have 6 oxygen right. So it's balanced. Now the question says, if I have 0.3 gram of H2S and 0.5 gram of O2, what is the limiting reactant? Okay, guys, here they gave us too much information. They gave us the amount of for each reactant. So for sure, this is the limiting reactant question. Then I start with the given numbers. I relate it to what? To product. But I have here 2 products. Which one I should choose? The first answer is doesn't matter, guys, which one to choose. But I recommend you go to the end and see if in the question they tell you which one to choose. If you go to the base says, the B says find theoretical yield, okay, find the amount of excess left over, okay, and then if the actual yield of SO2 is 0.25 gram, find the percent yield. So here in the D, they basically tell us which product to choose. If I were you, I would go with this product. For you can go with either of them to find the limiting and theoretical yield. But because the D already says that, you do not need to do more calculations, because if you go for H2O, for A and B, for the D again, you should calculate the SO2 for the theoretical yield of SO2. So you will kind of gonna do like I would say excess work here. So I would here choose the one that is given in if the actual yield. So I'm gonna choose this product. So I'm gonna relate each reactant to SO2. So I will relate my each reactant. How I do that? I first convert to the mole, then I relate it to SO2 here. So 2 mole of H2S to 2 mole of SO2, and here I convert to the gram, because as I said, it's better always, guys, convert to the gram, because in this type of question they always ask for something extra. So it's better to have already the question. But again, it depends on the question, guys. So 0.5, so let's do the other one, other reactant. Let's start with the 0.50 gram of oxygen. We convert to the mole of oxygen. I use the ratios. 3 mole of oxygen, the coefficient, and related to what? To SO2. Then I convert to the gram of SO2. So what is the limiting reactant, guys, here? H2S. Why? because it produces the smallest product. What is theoretical yield? 0.6 gram of SO2. So I already got the A and B here done. So let's go to the excess. Which one is excess here, guys? We already know H2S is limiting. Which one is excess? O2. So we're gonna start with the limiting reactant always. When you want to find the amount of excess left over, start with what? Start with limiting reactant. Then you find the mole of it. Then you relate it to your excess using coefficients. So you have 2 mole H2S, 3 mole O2. Then I find the gram of O2. This is the amount of gram of O2 that is used in the reaction. So then I subtract it from initial given O2 in the question. And it would be this much, 0.08 gram of O2 left over after the reaction. This much will be left over in the beaker at the end of reaction. You might, guys, find other ways to do these calculations. Until the answer is the same, I do not mind, guys, if you use different methods. So I look at the answer here, guys. If your answers is the same, your way is also correct. Your way of doing it is correct. So if you find another way and your answer is the same, is correct answer. Okay, let's do the D1. If it's asking for percent yield, so we know that the actual yield over theoretical yield time 100, and I'm gonna do that. My 0.25 gram is my actual yield of SO2, and I divide it by 0.60 gram of SO2 time 100 is 42% of the compound. This is, guys, what I'm gonna give in the exam, and make sure to practice enough for all of them. I have several worksheets on the platform, so make sure to do them, and they have all answers, and do enough practice of them. That's it, guys, for this part.